So if we have e to the x and we're differentiating it, the answer is just e to the x. If we have ln x, then the derivative of that is 1 over x. I'm actually going to ignore this middle row here, and I'm now going to go onto this bottom one. Now, what we've got here is e to the fx. Now, what I mean by that is it's not just x up here. So, for example, it might be e to the 2x plus 4. Okay, you may see an expression like that and asked to differentiate that. Are you all accepting that this 2x plus 4 can be described as fx? Yes? Jennifer, you with me? So this is a different function. Okay, so e to the 2x plus 4. How we differentiate that is we would just rewrite that e to the 2x plus 4. Okay, because we know that the derivative of e to the x was just e to the x. But then what we have to do is multiply by the derivative of this expression here. Okay? So what's the derivative of 2x plus 4? 2. Good girl, Cameron. So we would then multiply by 2. So my answer would be 2 e to the 2x plus 4. Not too bad? Because we used our rules that we just recapped. Power comes in front, take one off the power. So there is no power here, it's a secret power of 1. So it just became 2. And then remember, constant terms disappear anyway. Maybe we didn't remember that. So constant terms, because we're differentiating with respect to x, if there's a constant term, because it's just a number, we just ignore it. If there's any number of x's, it's always going to be the number in front of the x. Let me do another little baby example here before we look at the natural log. So for example, if we had e to the x cubed plus 2x. Okay, there's another example. So it's e to the x cubed plus 2x. So as I said, e to the x differentiates to e to the x. So this function is going to differentiate in first part as e to the x cubed plus 2x. Okay, so note we don't do anything, we don't change it, it's just going to be exactly the same thing. But we then have to differentiate this part and multiply by that derivative. So Jennifer, what's the derivative of x cubed plus 2x?
3x squared plus 2.
Nice, so we're going to put that in a bracket and stick it at the front. Okay. Now, if you like, you might want to just try and remember this in total, because actually the same rule applies up here, doesn't it? Because we've got e to the x, so it becomes e to the x, and we're multiplying by the derivative of x. Well, what's the derivative of x? 1, yes? So we still have 1 e to the x. So if you like, this rule, this one down here, applies to absolutely everything. Okay? It's more important when you have something different up here, so it's not just e to the x, but actually that rule follows for all of them. Okay, you all right? ln x. Okay, ln x. So if we have an example where we don't just have ln x, we've got ln of a function. Okay, so for example, we might have ln, oh darn it, okay, ln 3x squared plus 2. Okay, that's what we're differentiating, ln 3x squared plus 2. Normally the derivative would be 1 over x. So we're going to do a similar thing. We know that 3x squared plus 2 is going to go on the bottom. But what we're going to do is we're going to now multiply by the derivative of what was on the bottom. So the derivative of what was on the bottom, Camerona, what's the derivative of what's on the bottom?
6x.
Nice, excellent. So we're going to multiply by this derivative, so that's 6x. And there's our answer, 6x over 3x squared plus 2. Okay? Alright, so here's some examples. Y equals e to the 5x. So we're differentiating, so we're going to write dy dx. E to the 5x. Anyone want to do this one? And everyone's head goes down and pretend that they're writing something busy. Like it. So it's not just e to the x, it's e to the 5x. So we're going to write e to the 5x. But what do we then have to multiply by? Pardon? 5? Why 5? That's what's in front of x. Nice. Okay, our second one.
Is the 5 the same for every x?
Yep.
So the exponent stays the same.
Yes.
Oh, okay.
So that's really important. That is really important, and that's what lots of people forget, and that's what they make a mistake on. Whenever you have e, just copy that whole thing down, and then multiply by the derivative of that power. Okay, that's all that's how you differentiate e to the power of something. Natural log of x plus 5. Okay, so remember, it's going to be something over x plus 5. Yes? Because that's what we're taking the natural log of. And then we look to see what's on the bottom. What's the derivative of what's on the bottom? Pardon? Not 5. It would be 1. Why is it 1? Because it's 1x. Remember, we're differentiating with respect to x. Constant terms disappear. Alright, so this would be a 1 over x plus 5. Okay. d by dx. Remember when we had numbers in front already, they just stayed there until we were able to simplify. So we would have 3e to the x squared. Okay, so the rule applies. We just copy it down straight away. But we then have to multiply by something. And what are we going to multiply by? More than the 2. Remember, we're multiplying by the derivative of this. What's the derivative of this? 2x. So we need to multiply by 2x. That's a multiply sign. Jen, no?
Wait, is that 2x times?
That's 2x times. Sorry, yeah, it went all a bit pear-shaped. And then my big numbers I can now join together. So I've now got 6x e to the x squared. This fourth example, it's a natural log. So we're going to have dy dx equals something over 3x. Okay, because remember, there's something always, the thing that we're taking the natural log of goes on the bottom. What's going to go on the top? 3. Awesome. At this point, we then say, well, hang on a minute, I can simplify this. Okay, no, not just x. Be careful. Nice, Jennifer, 1 over x. Because these cancel, but we've still got a 1 on the top. Okay, the x still has to be in the denominator.